got yourself something funky. folks. It's time to kick it old school. So you can feel cool. Give it to me, baby. Baby. Yeah.
Guess what has 2 thumbs and totally updated Skype in the background to the stream? If you guessed me, you would be absolutely correct. And of course, I couldn't do this stream by myself, so I had to pull in somebody. So what's up?
Hi, how's it going? Yeah, no, doing good, man.
Good.
Thanks for having me.
Yeah, you saying that that it was, well, was it raining earlier up there?
Yeah, I got a lot of rain. Here's a weird thing. Last night we went out, because I actually have a life, and I went out and listened to a friend of mine sing at a coffee bar. And I came home and it was a beautiful night, clear sky, moon was out. I came inside and was thinking, I'm going to go outside and stream. And then all of a sudden I heard, must have been an hour later that I was getting ready to come back out. And all of a sudden I heard like water, and I'm thinking, uh-oh, what's leaking? And I went outside, the sky was leaking. It was raining. I couldn't believe it. Yeah, it's like totally unexpected. I don't know. It just moved in very, very quickly. You know? So it was crazy. And then I had one of my friends over, and he's actually a guy that works for the NSA. And he came up from Washington to hang out for a little while. And I'm sure that's going to go over well with all the people that are conspiratorial, but who cares? I'm just factual data. And he was here, and I had the scope running, and I showed him the moon and everything, and talked about P&K space imaging, of course, because it's the ultimate moon stream out there.
Oh, and, shucks.
That's it, man. It's true. Now you got that all sewn up. That's great.
09.
But anyway, so but then it clouded up and started to rain. So I had to have a new laser cutter in the shop because my old one died, and this one came off from Irvine, California. And when I got here, I had to take it off my truck with my my tractor to lift it out because it was a 500-pound crate, and then move it into my shop and uncrate it and set it up and stuff. And I just finished setting it up today, and it came like 3 days ago. Meanwhile, the observatory computer died, and then I rejuvenated that, so it's working right now.
Damn, who did you piss off?
I have no idea, because then my office computer died, my main computer. So I have no idea what's going on there.
Must be the government, right?
I was just gonna say it's probably your friend or the guy that's in the NSA. No, sorry. I know more about computers than he does, actually, so it's not him.
We actually have a lot of objects crossing. I'm believing most of them, what we're seeing, are birds, but we do want to get the timestamps down so I can check them again tomorrow. So if you guys, once again, you guys are great at this because you guys are eagle-eyed. If you want to timestamp them with the atomic clock that's up in the top left part of your screen.
That was a bird.
Yeah, timestamp those objects, no matter what they are. Because I like to go over, even if they are birds. I mean, even if they're plainly birds, I'd rather be safe than sorry when it comes to marking timestamps down. So if you want to hit those timestamps in the chat, I write them all down, and then tomorrow, you never know what we're going to find. It's one time somebody had timestamped a bird, and I think this was about a year and a half ago. And I saw it, I replayed it the next day, and of course it was a bird, but little did I notice in the background this little tiny circle moving slowly across the face of the moon. And I believe we later did identify, but yeah, so I mean, it comes in handy. So if you guys want to pop those timestamps, if you grab them, once again, I'll write them down the best I can, and then I try to review them tomorrow, and you never know what we're going to find. We're sitting on the wide field right now. The 12-inch is going to need a little more collimating done. Paul's working on it. He might actually send it off to get it done. Classic Mead. No, I'm just kidding.
hey, watch it, boy.
Yeah.
Watch it there, Buster.
Guys, finally a beautiful night for a stream.
That's great, yeah.
It's about time we get at least one out of the last 2 weeks where there's not clouds floating by. We've tried the last 4 nights, and we only lasted about an hour each night just because the clouds just would come sweeping in. So tonight is a welcome break, and I hope everybody is enjoying it so far. Paul is down there sweating like crazy because it's hot in Miami right now, and he's lugging around all those telescopes. Poor guy, I tell you, he has a dedicated man.
Out. Every one of them is out.
He has the 10 out, he has the 11 out, he had the 12 out, which it might still be out. He might still be working on it, and then of course he has the Orion, the 80mm out. So, yeah. So he's bouncing all over the place, and sweating, and I told him, I said, just go inside and let's do some crater spelunking, and that way he could cool off a little bit. So that's where we're at now. Here comes another one. He's alerting me. All right.
Oh yeah. Another, like, was it a bird or something?
Another object. Yep, I don't know, because he alerts me. That usually gives me about 20 seconds to see it, and it'll usually give the chat about 35 to 40 seconds until they see it. So
there's just a couple of things to mention here. Whenever you see stuff cross in front of the moon, there's a couple of things you can do. We know the moon's diameter in like arc minutes, basically. It's basically half a degree. Okay, so there's 60 arc minutes per degree, so it's basically 30 minutes across. Okay, 30 arc minutes across. That said, if we can just time the time it takes an object to cross a section of the moon, it doesn't have to cross in the center, you can then figure out what fraction of the moon it crossed in what time, and that could tell you how fast it was moving, and that can tell you how far away it is. So in other words, if you're looking for an object that's out near the geosynchronous position, and it would be basically, if it's not quite there, it would actually move slowly across the face of the moon because it's moving a lot slower. Things that are farther away from the Earth orbit a lot slower.
Let me ask you, when they put stuff in geosync, is it is that kind of stuff more above equator?
Yeah, I mean, the equator, is where they typically put them. And that's because they stand the best chance of, hitting as far north and as far south as possible. Mm-hmm. If you have something in a northern, say, geosynchronous orbit, which you could, you have to use what's called a great circle. And that is the largest possible orbital circle. It has to go through the center of the Earth, basically, where the center of the Earth is the center of the orbit. You can't have it kind of at a high latitude and kind of zinging around near the northern latitudes. It has to actually circle in a big, perfect circle around the Earth from, in polar orbit or equatorial orbit or any other orbit, any which way, in any inclination to the equator, up to 90 degrees, which is the pole. All right, but as long as it's out there, okay. The thing is, if you had something out 22,000 miles away, and it was doing a polar orbit, well, that's not geosynchronous at all, is it? Okay, because it's going from north to south, and so it'll just slowly move through the sky as seen from the Earth. Only if it's moving with the Earth. That's why geosync really means something that's like extending the equator out into space, 22,000 miles. Right. That's when geosynchronous orbit actually is true synchronous orbit. I mean, it's synchronous because it's moving at the speed of the Earth's rotation and orbiting at the same time. And that distance is determined by, the mass of the Earth and how fast it's spinning and so forth. How far out do you have to go to maintain orbit over the same spot of the Earth at the same time? Something moving north-south in a giant 22,000-mile orbit isn't going to be over the same spot all the time. The Earth's going to be rotating out from under it typically, as it always does. It's just going to move slower out there. So, that's how it works, And so geosync is only from the equator, only with the equatorial orbits. So you can't say that any other orbit other than an extended orbit through the Earth's equator is geosynchronous.
You know what? I wanted to. There's a couple of popular, I want to say conspiracy cases that I wanted to ask about your opinion on.
Of course you do.
Because we were talking about one here earlier in the chat. And have you ever seen the Mona Lisa video, by any chance?
I don't know what the Mona Lisa video is.
Supposedly it was and if my memory serves me correct, it was supposedly the Apollo 18 mission. That was, secret, top secret, Apollo 18.
Okay.
And this video shows two astronauts inside a capsule, actually coming down and landing on a ship that's on the moon. And then supposedly they found two bodies and they brought them aboard their craft. And they were kind of... You have never seen this video?
I have not.
Okay, I have to send that one to you. So obviously I don't want to talk about that one if you haven't seen it.
It sounds like a good plot for a movie.
But some of the more popular UFO cases, just to get your opinions on, who was the guy back in the 60s and 70s that was, saying he had contact and he was taking video of spaceships? And
you got George Adamski.
That's who I'm talking about. Yeah, George Adamski.
Okay.
So,
okay.
I mean, you've probably come across that information somewhere, right?
I have seen some of the Adamski stuff. Yeah.
So, what's your opinion on the whole Adamski situation?
I felt that that his photos were not convincing for me, because it looked like he had been photographing a model, like Billy Meyer does. And I just felt that they're kind of peas in the same pod. They're just, I don't know what it was. They needed some kind of a following or whatever. And Adamski was partially successful. I think Billy Meyer was even more successful at getting a following, perhaps because he was a quaint little old man. And as we know, old men don't lie. So clearly that's part of the allure, right?
Right.
So I don't know. I've never. It just wasn't convincing. The Adamski UFOs always looked to me like models, or just fakery.
Mm-hmm. There's one I saw from the Adamski tapes that really kind of had me questioning it a little bit. Was when he was supposedly filming this craft, and you could see the bottom bulges actually moving in and out, on different ones. And that one kind of got me a little bit. I was like, okay, well, we're talking about, what year was this thing actually, and having moving parts to it. It was pretty advanced if it was fake for the time. And
okay.
Oh, here comes another one.
Oh, is that him beeping you?
Yep. Holy crap, he's beeping me like crazy.
You sure that's not his pacemaker going off and saying his battery's low?
It might be. Him running around like a crazy person. Yeah.
Well.
So I mean that video when it came out. But let me ask you: is there any high-profile UFO cases that you say, yeah, this probably definitely could be legit?
Not really.
No.
And it's not because I'm just an unbeliever. I certainly believe that they're here, and for a lot of reasons. I mean, if you saw the article that the UK Sun did on me a couple of weeks ago, you saw that I was clearly sharing information that I felt indicated that not only are they here, but we're tracking them.
Yeah, it made you security famous.
I know, that really was just such a.
Are you going to do the interview on Secure Team?
Of course not.
No.
No. I'll let him. If he wants to interview me, he can come on my channel and interview me. We can do that.
Well, I'm wondering if it wouldn't be good for that channel to have a dose of facts.
Well, you know how he is. They're gonna just massage it any way they like. And yeah, there was a few objects flying across the moon, but I guess he's just over a marsh or something.
Yeah, I mean it could be. As I said, I mean most likely they are birds, but I'd rather check them a second time just to be sure. And
I wasn't changing the subject. I was just saying, I just don't want to. I don't think I can do an interview. But person, like I said, if he wants to do an interview, I'll consent to it if I'm doing the stream and he wants to do it on my channel. Because with all the people he's got on his channel, then he can drive a few to mine.
Right.
And I had one person comment on the video when I wrote a comment on the video, saying that, hey, we'll talk about this stuff and more. Just come to Sky Tour live stream and check us out. And some guy commented, this isn't no soliciting. He said, no, you can't solicit here. And I wrote back and said, yeah, but the video was all about me. So I think at the very least I'm allowed to say this, don't you think, buddy boy? This one. So it wasn't him. It was one of his minions trying to play boss for a minute and get himself all excited.
Well, that's one thing about it. I mean, he does have a loyal following. I'll give him that.
Yeah, but are they the kind of people that either of us want in our streams? That's the question. I mean, it's the kind of people that keep it, open-minded. Because I'm pretty sure we pretty much keep it open-minded too. Yeah.
But we're not going to jump to conclusions either. You know what I mean?
Yeah, no, they just have the conclusion before they even start to think about it.
Yeah.
They say, wow, look at that UFO, and this is why it's a UFO. Instead, they don't say, wow, look at that interesting phenomenon. Let's figure out what it is.
Yeah. And
that's
the sad
a
part
problem,
is, I mean, he has been caught before, faking stuff, and that's what's kind of hard with the credibility issue. But he was on a trek last year, for a while of actually posting stuff where it was actually research, and I was like, oh, maybe he turned a new leaf, and then this year came around, and it was we started turning back the other way a little bit. But I mean, I find it interesting either way, but
Well, it's always good for conversation, but it's not good for science. But I will say this, if anyone wants to say to his credit, I mean, he actually did say only what was in the article that they wrote on me. He didn't actually embellish it or add to it, which is okay. That was fair, And he called me Mr. D'Antonio all the time, which is like, I don't know, maybe he's 16 or 17 years old. I don't know. But I don't know what it is, or maybe he just wanted the interview. I don't know, but I haven't gotten back to him on that. Don't think I will do it on his channel. I'd be willing to do it on my own.
I would say you could almost agree to do it on his channel if you promise it won't be edited.
Well, I mean,
because that's a lot of people you could point towards. The Sky Tour live stream.
I could, but then the question is,
border people that aren't
are
exactly
they the kind of people we want?
Well, you never know, because I got this channel got a big bump from a channel in Brazil that's a pure UFO channel. But the people that came for the UFOs, they easily left within a month, and the people that were still interested in astronomy stayed. All
right. Well, that's fair.
So I mean, it's a give take. Yeah, you're gonna have the UFO people, that insist everything's a UFO no matter what it is. But on the other hand, you do have people like normal, just people that like space and are interested in that kind of stuff that know some of the stories are fabricated and out there, and but you do have people that still have that interest. So I don't know. I mean, it might be good for you.
Well, I will say this. I am currently, in an organization that has a lot of people that are fairly open-minded, but there's a select group that is actually very closed-minded, and everything's a UFO no matter what you say. I mean, I make my bed in that arena with the Mutual UFO Network because most of the people are very good, and most of the people are good thinkers. They're very dedicated to the cause. However, there are many people, many people in there that are very closed-minded. Not talking about high in the MUFON echelons. I'm talking about in the field investigator teams out in the different states. There are people that take photos and think that everything they see is a UFO, and some of them are my good friends. And so it's like, oh boy, here we go again. I gotta break the news to them that no, actually that's Arcturus. I can prove it. 7 different ways, So I mean, sorry, pal, But it's okay. I have one friend of mine actually. He's a hunter, and he goes up into the Wisconsin woods, and he actually had sightings of creatures on the ground. And I said to him, "Do you have these on your game cams?" And he said, "I don't yet," or something like that. And he says, "But I'm going to go put in new cards, and I'll change them all over and get them up and running," which he did. And he caught some creatures on his game cam. And there were like three creatures standing in the distance. I told him, "Send me the photos. I want to see the photos. Send me the photos." And he has yet to do it, but I'm interested in that. And I don't doubt. Okay, first of all, if we haven't seen them yet in hundreds of years or even thousands of years of visitation, if we haven't really been able to definitively say we've seen them, it doesn't mean they're not here. It just means that their techniques for getting here and maintaining their cover are just better than ours, and or they're using a system that doesn't allow for our conventional vision systems like cameras to capture them accurately. And that's why UFOTOG, which we're renaming to the Aerial Anomaly System, the Aerial Anomaly Detection System. That's why that system is going to be instrumental, because it's going to rely on instruments. It's going to rely on seeing one object in the sky that may look anomalous, but seeing it with 4 or 5 different instruments simultaneously, getting data from it. Is it emitting radiation? There'll be an instrument that just detects that. Is it changing? Is it moving into the infrared or into the ultraviolet or into the visible and back and forth? There'll be an instrument that detects that. Is it causing a change in the local magnetic field? There'll be an instrument to check that. The local gravity field. Are there gravitic changes nearby?
What's the timeline looking like for this project?
Well, as I thought it was going to be done 3 years ago. That's what I said before. But as we got deeper into it, we realized, you know what? We really got to take this slow and easy, because if we're going to do it right, there is so much to do. So my focus right now is getting the proper camera chip vetted. I think we've made our choice. I talked to Doug actually just a few days ago on the phone, and I told him about the renaming idea, and he's okay with it. And he's because we want to get scientific, institutions involved with this. You're not going to get that if you name something the UFO detection system.
I know, it's sad, isn't it?
But that's the media's fault, okay?
Yeah, well, that's why you have a lot of them changing, to unidentified aerial phenomena, or
right.
It's just
Now your folks in the chat, all the people in the chat, okay? It's like, hi guys, it's good to see you actually. And I saw some of them said hi to me, so that's wonderful. Amanda's out there. I see, Dapple is here. I saw Sherry's here and so forth saying hi. So I haven't forgotten you. I didn't miss you. I just had to, talk to, Mr. Time Sink here, Keith.
Sorry.
But no, I'm kidding. It's your show. And I was just actually thinking, if you guys in the chat, what's your opinion? We used to call this the UFO detection system, UFOTOG, which was Doug Trumbull's original name for it. UFOTOG 2 was our, joint project we're working on. But I think we want to call it the Aerial Anomaly Detection System. I know it's longer and so forth. It's like turning shell shock from World War I into post-traumatic stress syndrome in the Vietnam War, and it goes to bigger words and so forth. Hey, Darryl. But the question is, if we say aerial anomaly detection system, you know what that says to me? That says to me that now anyone who has scientific funding or funding from a national endowment of some kind can look at us and say, well, what kinds of things are you going to detect? Well, we can detect that killer asteroid. We can look for asteroids. If we set these up all over the planet and just take footage nightly, we can look for special, different radiations, so we can see gamma ray bursters in the universe. If they're missed by the astronomers, we'll catch them. We can look for meteors.
Do you think you're going to have a problem with any kind of government thing?
Well, we already had the Defense Department call us.
Yeah.
And they wanted to set up a meeting, and we said, no parlez-vous français, señorita. No, we didn't. We actually, we just said that, we're not ready yet. We're not far enough along. But, clearly
so they have an active interest in what you're doing, obviously.
Yeah, they do. I mean, and we do have, former government scientists on the project. So clearly that's an interest to them. That they want to know what these guys are working on now. I mean, one of the guys that's on the project, and for crying out loud, this guy stopped the Chernobyl meltdown in the 80s when the Russians couldn't do it.
Right.
Okay. This guy's team went over to Russia and stopped the meltdown, saved probably 100 million people, but he couldn't get the Nobel Prize because it was a classified project. And he was happy to get his salary in full in perpetuity when he left the laboratory.
I'll tell you what. I mean, between what you guys are doing and what Dave Schock and them are doing with the CubeSat, it's like if there is something out there, and something is A.K.A. visiting, it's gonna be found. And these two projects are the most likely thing to do it.
That's
for the public anyway, because obviously you said now I know Dave's is straight information that's being fed right from the CubeSat into whatever and then posted online. Is that how yours is going to operate too?
Well, he's got one CubeSat. We're going to have maybe initially we might have 10, we call them platters, 10 platters out in the field somewhere. Mm-hmm. There might be 2 in Arizona. There might be 1 in Missouri, 1 in California. And several in Utah and Colorado, other states.
Are you placing them intentionally in like UFO hotspots, or are you just kind of I mean, is there a way that you're kind of just trying to arrange them that you can get the most coverage, or?
Well, see, here's the thing, Keith, and you're right. Okay, do we choose to go into hotspots, or do we choose to find, or just get them out there and just start observing?
Mm-hmm.
All right, and I think we're going to get them out there to just start observing, but have several in reserve that we can send overnight to a hotspot with a rapid deployment team. Now, the Mutual UFO Network has rapid deployment teams. We have two. We have the STAR team and we have the SAT team. Okay, and the SAT team handles one type of occurrence, one type of flap, if you will, and the STAR team will handle other types. Now, I've been a STAR team member since the STAR team was formed. That was years ago. But the thing is, we want to make sure that we get these units into the field right when something's happening. So it'll have to be quickly deployed. Now, people have all kinds of issues. They say, well, these UFO things, they can shut down any electronic equipment in their vicinity. Mm-hmm. Yes, I believe that's true. But I also believe that they shut down electronic equipment that is of substantial size and has a footprint, an electromagnetic footprint that you can detect. Now, that means if it's an active radar pinging something out there, then it can shut that down. All right, they'll be able to shut that down. We're passive.
Well, let me
We're
ask you something real
receiving
quick.
signals. We're not transmitting anything, so they shouldn't be able to see us.
What if? Okay, once again, I hate to deal in hypotheticals, but let me just
go
throw
right
this out
ahead.
there. What if, you need this rapid response and you have your equipment that you're working on ready to go, and say it's close to you guys, and you guys get there quick? What happens if you get there and say some random government agency, doesn't matter which one, pick one, says no, you cannot put that here? What would that tell you, or what would be your plan B if, say, a government agency is telling you cannot place that here at this, with what's going on here or something?
Well, see, here's what I suspect will happen, and I'll tell you the answer to that. What I suspect will happen is they're going to say, can we have one of those units? And then we'll say, yeah, sure. And
see, that's
then
what I'm afraid of. 'Cause I'm
ever...
afraid of they'll be
Well,
there,
then-
like, okay, you can do it, but all the information has to go through us first.
That's the thing, though. That's possible, but I can tell you this: they could take the whole thing over and just steal it out from under us and do their own. But
And
they're
they
not going
have
to do
done
it.
that many a times before.
They're not going to do that in an obvious way. We would still be doing our data, and our data would still be coming in. They can't stop a gamma ray in the middle of the atmosphere from something that enters the atmosphere. They can't stop a gamma ray being emitted by a dimensionally shifting craft that's entering our normal XYZ space. They can't stop that.
Maybe you guys should build a ghost device. So if you come pulling up and you see a whole bunch of government, you bring out the ghost device. They take it. You say, "Fine, we're stepping away," and then you drive 2 miles down the road and put it out. Put out the real one.
Well, that's the thing. One of the scientists on our team actually invented something called. It's a special radar, and it has a 2,000 foot range, and it's a sphere around any object that it's mounted on. And the thing is, it's a passive system, and he sent active units to one agency, and they called him and said, "How do you turn it on?" And he said to them, "It is on. It's been on since I sent it." And sure enough, it was. They just couldn't detect the power output coming from it because it works on such a low freaking electrical frequency and frequency, electrical charge, so low milliamps. Yeah, but the whole point is, the whole point with that is that if they wanted to take something and steal it and use it, well, that's one thing. But if we were just people that would say, well, we'll help you. Let us do it. We'll do it. But our stipulation is that for stuff that isn't related to black projects, we won't divulge under penalty of law any black projects that are your projects. Mm-hmm. All we want to divulge is the things that are happening in our skies that no one understands.
How do
That's
you protect against wrongful claims that it is a defense project when it actually isn't? Okay, how do you say something comes flying across the sky and you catch it or whatever, and obviously the military doesn't know what it is, but they say, oh, that's one of ours. You can't divulge that.
Well, you see that.
Would you make them identify it?
Well, here's the thing.
Or?
Well, that would be if we were to do this, through them or with them as quote unquote partners, which I don't approve of. Then they would have to, as part of the agreement, they would have to provide to our science team all the parameters that would indicate that it's one of theirs. And so, in other words, they would have to come up with documentation, in like a 24-hour time frame.
And even maybe a flight itinerary, right?
Yeah, or no, because that could be faked in 30 seconds. They come up with some type of let's say science principle that they're using that can be confirmed. That is something that we could confirm. Now
that would correlate with the information you gathered.
Yes, they would correlate with what we gather, and our science team would be very smart about this, and they would say, well, actually, we don't see how that would produce gamma rays. The gamma rays are very high energy. There's nothing that we do on Earth that produces gamma rays other than play with nuclear reactors at times. Okay, so I would like to know, what process it is that you say you're using,
right.
And if you won't tell us, then I will have to assume that it's not one of ours, because if you won't play ball, it's because you don't know either. And so that's when we just go public with the information. They can't stop us from developing the project,
right.
Okay, and they can't stop us from gathering the data.
I just wanted to know that you guys have a plan in place if this were to occur. Like, you guys have thought about this, obviously.
Yeah, Doug and I have talked about it in the past, and see, it works like this, and they're thinking the same thing. You keep your friends close, you keep your enemies closer. So, they're not enemies. I mean, they're on the same side, but they just have this paranoid secrecy that they like to pursue, and they're legitimate reasons. Okay, I'm not going to say they're not, because
right.
I've seen one too many times what happens when secrets not meant to get out. Because I worked in that arena for a long time. I'm still in the naval arena. I'm still in that arena, but I don't, I actually don't deal in classified material anymore, and that's by choice. Right. Your life isn't your own when you're doing that, and I don't want to be told, come on down Saturday morning, I'm gonna give you a polygraph. What for what? Just because. Yeah, I don't know. No, so that's okay. But we have our plan, our contingency plan for if they're gonna try and say that this is theirs, is we're gonna have the data, and we're gonna know, our scientists are gonna know whether the data conforms to anything that's even remotely possible. So in other words, let's give you an example. If you see a light going across the sky, it could be an aircraft, it could be a satellite, but then if that light just winks out, then it could have been an iridium flasher, and maybe you caught it right near the end, okay? Or if that light winks out and you get a burst of gamma rays from that location in the sky at the same time, and by the way, the local magnetic field twitches a little bit when that happens, well, then we know that something did a dimensional shift. And there's nothing that we have in the arsenal, our military arsenal, that can possibly do that. Nothing. Okay? And even in the black world, there are no dimensional shift projects, much as everyone likes to say there are. There's nothing like that going on in the black arena. Because the energy requirements are beyond our own. They're beyond the energy requirements. We don't have the ability to harness the energy that we require to create that kind of dimensional shifting.
It just got me so excited thinking about, what if one day you have, say, an object or whatever that can be corroborated by the project that Dave Schock is working on. Imagine having both of those pinged.
Well, see, that's what Dave and I talked about. Dave's going to cover the orbital arena, and say he sees something, and at the same time we catch something on the ground. Mm-hmm. Now, mind you, we would like to set up units that are on the ground that are along the orbital track of the CubeSats. Okay?
Right.
Now, ideally, it would be great if Dave could deploy off the space station, but that's not to happen. Because if he could, then he could just drop a whole flock.
Right.
Now, that's what they call a bunch of satellites together, and they drop into a flock, like geese.
And for anybody that doesn't know what we're talking about little CubeSats. You can look them up on Google if you want to. That's what is launching. Our friend Dave Schock is doing a CubeSat for disclosure, where this CubeSat is going to have all kinds of little gizmos on it, and it actually is going to be put into orbit to detect things. You can read more about it. I'm pretty sure Amanda or somebody can find you guys the link if you want to read more about it. And then Mark's project is actually going to be ground-based, correct? That's correct. And we're going to let the Earth's rotation show us the new elements of the sky. It's a slower process than the CubeSat, but we can literally, be on the ground for years. But with that being said, but with even just one of these projects, but now we have both of them. This is a giant leap forward for ufology. If we are going to discover something. Now, that's once again not saying we are going to discover anything, but if it is there, these two projects are meant to detect it and meant to detect it publicly. Not under any veil of secrecy or, is there going to be a main site with your info?
Actually,
or is there,
that's a good question. I'll tell you. First of all, we want to vet all the data that comes in, so we are going to have access to the data first. Why? Not because we want to hide anything. We're going to make everything disclosed. That's our goal. No, this data belongs to humanity. It doesn't belong to us. It doesn't belong to Doug. It doesn't belong to me. It belongs to humanity. But we want to vet this stuff because if we see something that looks promising, we owe it to everyone who's going to look at our data to have given it the most thorough scrutiny we can. And I'm talking 5 years worth of analysis. I'm talking, a process through which we actually bring aboard scientists who will vet, verify, look at our data. Guys like Michio Kaku, guys like Stephen Hawking, if he's still around, when we finally get our units out in the next year or two. But the bottom line is, we wanted to have a real science team, but we're not going to have a real science team with the name UFOTOG.
Right.
Aerial Anomaly Detection System, on the other hand, any one of the science teams can look at this from a different point of view and say, I want to use it to hunt for asteroids. So they'll look at our data. They'll take down our data and do analysis surveys of our data to see if there's asteroids out there that were not previously seen or orbits not previously seen. Maybe we have data that they didn't catch, that kind of thing. And so...
what would be, as for, you said there would be real science behind this, do you have names of people that are scientists actually on board for the data yet? Or you, or what would be your criteria, say, to have somebody come on board?
Well, I'm actually hoping to talk to Michio Kaku soon. And I've got, Bill, New York Skywatcher, in fact, is actually got a contact who knows Michio Kaku, and I'm going to talk to Michio Kaku and ask him to be part of the team personally. If I can get an appointment with him, I'm going to go down to see him in New York and sit with him for a little while and explain the project and basically tell him what we're doing. Now, one of the most famous UFO people in the world is Jacques Vallée. And Jacques Vallée has he basically agreed to help us 2 years ago. And so he's on our side. He's going to be helping us. So he brings a level of credibility to this too that is, we need. But you got the word UFO tied to it. But see, Jacques is not really. He doesn't think UFO. He thinks dimensional type stuff. And so which is great because that's kind of where I am. That's where Doug is. And although we don't know, we do know that there is a particular process they're using that we don't know yet. Now, Michio Kaku, on the other hand, he thinks that string theory is valid, and that's where. Thank you, D. Thanks for the comment, D. I saw that. That's where when we look at what Michio Kaku believes in with string theory, he believes he knows that that's where any type of advanced propulsion will have to come from. It's knowing that theory, being able to leverage the new physics that would be involved in looking at what's involved with string theory type propulsion concepts, that makes it something that brings traveling anywhere in the universe in a short amount of time more realistic, which to us sounds like super duper sci-fi fantasy now. But don't forget, the universe is 13.8 billion years old. Earth is 4.6. Okay, that means we came along after 9 billion years plus of the universe had gone by. So that being the case, we're latecomers to the universe game. And so in the time from when the universe started, probably 2 billion years in, maybe a little more, to 9 billion years or so, maybe a civilization had arisen in there, lived and died, or lived and moved out to the entire galaxy, and then moved to the whole universe, or moved to alternate universes through parallel gateways that they had opened using high energy systems and leverage of knowledge of parallel universes. Now, that stuff doesn't sound far-fetched to me, and the reason it doesn't is because it wasn't too long ago that I looked at a paper in the Astrophysical Journal, I believe, that actually discussed parallel worlds and parallel universes, and it discussed why this team actually believed they exist. They weren't nutcases. This was an established, serious research team, and they said there wasn't enough mass in the Big Bang to cause the Big Bang. The only way it could have happened is if more universes were spawned when the Big Bang occurred. That leads us to another thing. Several years after that, another paper came out, and that was a paper that said, yeah, we agree with the first paper, and here's how we think these universes are laid out relative to each other. We think we understand the topology. and the way you might think of it is, you remember those old bubble pipes you had as a kid? Maybe you blow bubbles and this big pile of suds comes out at the end of a bubble pipe. Mm-hmm. Well, think of each bubble as a universe. Okay? If you look at how those are attached to each other and how that works out, how they are joined to each other, they're joined on several different surfaces, and they kind of overlap on several surfaces, and then there's one part of the bubble that sticks out above the others and is alone. Okay? But all the bubbles on the inside, they're firmly interconnected to every other bubble on every part of their surface. In fact, they exist only because all the other bubbles are actually holding them and suspending them. And that is more like what the universal multiverse would look like, is that type of interlocked, interwoven network of basically universe bubbles. And then
so you're basically saying that in that kind of thinking that a parallel somehow could open up and somebody could accidentally slip into another dimensional plane?
Not even accidentally, but in reality, they would actually utilize it to travel between parallel universes. Keep in mind, one of those little tiny soap bubbles trapped amongst all the others is our universe, perhaps. Mm-hmm. Our universe is vast and endless as far as we're concerned, because we've only been here for, basically 60,000 years with, of quote-unquote written history, if you count pictographs and caves, okay, or 6,000 years from, the origins of language and so forth, other languages. But we don't even all speak the same language, so we're just getting our feet wet when it comes to being a civilization, as a matter of fact. So now, if we look at that little tiny bubble that's us in the center, the notion of traveling to the limits of our own universe are a far-off, distant prospect for us. Mm-hmm. Okay? For another civilization that had 1 billion years of development, again, we have at most 60,000 years if you count pictographs and caves and etchings and petroglyphs and rocks. All right? If you count that amount of time, we already see the possibilities in string theory within 60,000 years of existence that this stuff can be something in our distant future. Well, another civilization's had another 1 million years on top of that to research and bring this to fruition, provided they got through all the trouble spots that civilizations face. Then I think they would probably be all over the galaxy and would have leveraged this, would have learned how to create warp bubbles, would have managed to figure out how to do this trans-dimensional warping using multiple dimensions within a string theory construct if string theory is valid. Okay, we don't even know if it's valid. We just suspect that it is valid. Michio Kaku believes it's valid. I mean, that's and the man is no dummy. So we have the option down the line of leveraging this technology at some point. Right now we don't, because we just don't have the ability to harness the right amount of energy. So.
Did you get a chance to see what I was talking about with my with my idea for one of the topics for one of your live streams? And I should also mention before you answer that on us right now, for anybody that doesn't know, is Mark D'Antonio. You can see him. You can see him on NASA's Unexplained Files and One on Earth, I believe. You just did the newest season of that a little bit ago, correct?
Yeah, I actually just taped the last half of season 4.
Yep. And then, of course, FX models, and I mean, what don't you have your toe in these days? But he also has what I personally like is the Sky Tour live stream on YouTube, where he takes a look at a lot of deep stellar stuff, and it'll blow your mind. If you want to learn something, subscribe to that channel. You will get an education, not only on astronomy, but also astrophotography as well. So,
yeah, I show people how to do that. I don't hoard the technology. I'm very happy to share it, and I want people to understand it and enjoy it. And it's really kind of fun.
Absolutely.
Yeah.
But did you? With that being said, did you get my idea for a topic for you? Because I'd really like to hear you discuss it. And I don't want you to discuss it here because I think it'd be a really good for your channel. Did you happen to see it at all?
I'm trying to see where you sent it, because I did not.
I'll tell you what it is. It's basically, I was reading. Of course, I get lost. Like I start reading about something, and 3 hours later, I'm still going with it.
When you emerge from the rabbit hole, yes.
Yeah, but I was reading about.
That's beautiful. Look at Plato. Holy cow.
Yeah.
Sorry.
I was looking at basically latitudinal gradients and atmospheric wind speeds. And, this whole thing was talking about how depending on, the speed of the wind and the rotation, that you could actually get fairly straight lines in nature. And with me reading about this like almost perfectly explained Saturn's hexagon. And I just think it'd be a really good topic for you to discuss those winds and the gradients in them, and how stuff, because I don't know, because a lot of people.
Oh, you did tell me this.
People almost always say that no straight lines in nature, which isn't exactly true.
No, it's exactly wrong.
Exactly.
I mean, just look at the moon Pan. Okay, I mean, was it Saturn's moon Pan, right? Okay, Pan looks like the Death Star because it has a raised ridge exactly around its equator. A perfect raised ridge all the way around its equator. And people say it's artificial. It's got to be. No, it doesn't have to be. There's a reason why that could occur, just like you see it, and I can tell anybody how that works and how that's possible. And actually, how we think it happened. See, so that does happen.
I will say, from what I was reading and from the scientific papers I was reading about this, I will say the largest they discovered is 8 sides that these gradient winds could produce. From different aspects. So, but you're figuring from 3 to 8 sides, you're talking everything from triangles to octagons. And it just clicked right then and there that okay, that totally explains Saturn with its wind speed. Now, does Jupiter? I mean, I'm not read up on Jupiter as much as I have been Saturn lately, but Jupiter does not have a hexagon, correct? Or does
correct. It doesn't seem to, but I'll tell you what it does have. It has this really interesting deep blue at the poles, which is very interesting because it shows different chemical constituents there than elsewhere, causing that blue. And as far as what it is, well, there's some ideas, but I don't really know specifically what is the blue. I mean, I know about the ammonia compounds that are causing the brown and some of the white actually too. I also understand how the cloud bands are the white bands are generally higher and the darker bands are generally lower, and they represent a steep wall basically. wind-wise, and because of the way, in fact, the way Jupiter in particular, and this leads to the hexagon question, the way Jupiter in fact particularly formed, there's bands that go the opposite direction from each other, right next to each other.
Yeah.
At very high speed, hundreds of miles an hour the other way. So there's tremendous wind shear along the border, and you can actually see in the close-ups all that very turbulent eddies in between the cloud bands. Okay, you can see this very turbulent area where the stuff is being stretched and pulled.
Can you imagine being on that line?
Oh yeah, I always think about that because I have no life.
But they're almost so detailed where it looks like if you were, now this is just hypothetical once again, but if you were standing in the middle of that line and you put your right arm out and your left arm out, they would be ripped different directions. You know, that's how defined those lines are. It's amazing. It's how defined they appear to be, but of course, right.
You know, Jupiter is like what 90,000 miles in diameter or so. So when you consider those things that looks just so fine line, when you get up close and personal, you're really looking at a very dispersed, miles wide feature that doesn't have the same kind of definition. In the same way that puffy white clouds in our sky, from 3,000 to 6,000 feet away, that the cumulus clouds are, look very sharply defined. But when you get up in them,
but even
they're just fuzzy edged,
right?
You know?
But even for storm, I mean, this is I guess I worded it wrong. But for storms, they look, for how close they look.
Yeah,
it is a very defined line between the bands.
Oh yeah,
it's for the size of the planet and the speed. I mean, Jupiter's spinning at what, like, help me.
Oh, it was a 9 hour.
It's a 9 hour. 9 hour and 40 some minute or 50 some minute rotational period. But I mean, you're talking. I mean, just I wish we had the craft that we could actually go and just let's do it. When we actually had the power to get out of it, then eventually, but it's not going to happen.
No, I would love to explore the inner atmosphere of Jupiter and actually see what's really in there.
It's amazing.
But
I wanted to bring back that. But before I forget this. So there's a hexagon on Saturn.
Yeah.
Now there's also a hexagon on Neptune, or is it Uranus? One of those two has one as well. But once again, not at its north pole. Or, I mean, not at its south pole. They're always at the north poles, and I wonder why that is.
Well, that's where I was going before, but I got sidetracked again.
Sorry, that's probably me.
No, it's okay. I mean, you have all these wonderful things you're saying, and I answer them, and then I forget where I was.
Well, you got to remember too that I today is Saturday, so I did the whole early shift and work all day and came home. So I'm on my fifth win by now.
Primed.
So we're good. Yeah, I'm primed to go.
Cool. No, see, the thing is, there's resonances that are set up in atmospheres, in moon orbits, in the solar system as a whole, and these resonances dictate where things go, how things behave. So, for instance, Jupiter's Galilean satellites, they're in a resonance to each other. Saturn's satellites, okay, they're in a resonance. The inside the rings, there are moons, shepherd moons. They're in such a resonance that two of these moons actually swap positions, swap orbits. Mm-hmm. Every seventh orbit, I believe, or something like that. And one moon goes from a higher orbit to a lower orbit, thus moves faster, and one moon transfers using that gravitational whip from the first into the higher orbit where it slows down. And then like 7 orbits later, it does it again. And this is like this swapping has gone on for a long, long, long time. And it's really interesting, how that happens. So we have resonances. A lot of the moons that we know of, our moon, okay, is in a resonance with the Earth. All right. In our case, that resonance creates tidal locking. Mercury is almost tidally locked, but not quite. In fact, Mercury actually does have a period that's different from 88 days that it goes around the sun. It actually does have an actual rotation that takes it out of the tidal locking definition, which is something many people don't realize. But the thing is, it's important to understand that these resonances, these base mechanisms, dictate the orbital mechanics and they also dictate the atmospherics in some of these planets. I think that's important to know. You know, and so the hexagon on Saturn is due to some of these resonances that occur within the atmosphere of Saturn. Atmospheric resonances that are, for instance, perhaps related to the moons and how they act on the planet. All right. You know, in the same way that Saturn's moon Enceladus, for instance. Enceladus is only 300 miles across, but why does it have liquid water? Why in the world would it have liquid water? I mean, it's a frozen wasteland out there. The temperature is so cold that you wouldn't survive more than a few microseconds, you know, exposed in that environment. All right, even if you had oxygen atmosphere, it would be raining out and have, rained out to the ground like snow. All right. So how is it that Enceladus has water, for instance? Well, it's because of a resonance with Dione, all right, another moon of Saturn. And what happens is, as Enceladus comes around, Dione pulls it away from Saturn just enough so that Enceladus's orbit becomes slightly elliptical. So as it gets closer to Saturn, it gets pulled by Saturn and squished. And then as it goes away from Saturn into a slightly farther away, it relaxes and goes back to a round shape roughly. And so this constant flexing of the moon heats the interior. You don't think it's a lot, but on a planetary scale, it's a massive amount. And that's why we have a lot of water underneath the crust of Enceladus. And that's why we have the geysers that spew this water into space. And then you'll say, well, why doesn't the water run out? I mean, certainly if this has been going on for so long, shouldn't the water run out? The answer is, well, you'd think so, except when you look at other imagery from Enceladus, you see that Enceladus is traveling through that same water that it spewed, and it's reclaiming some of it. Some of it escapes, but some of it is getting reclaimed. So over time, you know, maybe Enceladus will evaporate, or maybe not. Maybe Enceladus was a lot bigger, and we are seeing the evaporated Enceladus. Maybe it was 7,000 miles across or 700 miles across, I meant to say. And thus it's evaporated down to, say, 300 miles across. Over time, maybe that's happened. We don't know. Okay? So, and that's the mystery, okay, that we're looking at. But all of these things that happen are due to resonances. This interplay, this cosmic dance, I call resonances cosmic dances. They're dances. The dance between Dione and Enceladus, you know, has caused this squishing process over time to be kicked off and started. And so, and that has to do with the resonance, that is the dance that they do. In the same way, in the atmosphere, the hexagonal patterns at the poles, interesting, unexpected, but probably due to some type of dance between the different elements within the atmosphere, the different elements as in chemical elements, but the different bands and systems, subsystems within the atmosphere, like we have.
But dare I say, definitely
air currents and so forth.
Yeah, they are definitely due for some more investigation into them. Correct?
Oh yeah, because you know there's no.
It's not like they saw them and found them and it was like, okay, this and then this causes this and okay, now we know there's, and just leave it alone. You know, they're definitely diving into, if not more than what they were. I hope.
No, but you know the thing is that you know in Saturn's case, you know, science was going back and forth for a long time on what that hexagon, where it came from. Mm-hmm. You know, now if you look at the way liquids work, okay, you can mix liquids up and you can watch liquids actually start to create strange geometric patterns. All right, that's pretty cool. So there's no, there's no direct correlation to how it's working on Saturn that way.
Mark, do me a favor and keep your eye on the screen. There's an object coming across that's actually pretty slow, so it might be a satellite. Just while you're talking.
Yeah, all right.
Just to be sure, I want to make sure that you see this one.
All right, I'll look for it. I can walk and chew gum at the same time.
And you are the best at that. And you know what? While we have this little area, I want to ask the chat. Me and Mark have talked about these 3D craters that he prints on a 3D printer.
Oh, they're beautiful.
And,
I did Apollo 17's landing site just the other day.
What we were thinking about doing is actually offering them for sale for people that might want them. And since we have a pretty good crowd tonight, I figured I might as well just ask the crowd. Would that be something you guys would be interested in?
Now I have the Moon, I have Mars, I have Pluto, I have Ceres. A.K.A crater on Ceres, the one that has that white stuff sticking out. I have a beautiful print of A.K.A crater that I did, and it's a 3D print, so it's 3D relief. But this is actually NASA data, and I'm working with the guys that actually have they are the stewards of this 3D data at NASA. All right, and they're actually part of the U.S. Geological Survey, believe it or not. So I'm working with these guys to help them study the stuff. And with the Moon, you can see craters from plus 60 down to the equator, and then from the equator down to minus 60 standard. However, I know you want Cydonia, Amanda. I know you do, and trust me, I can get that for you. Now, the thing is, though, I asked them about the northern locations, and then what they did was they put together a bunch of links for me, and they sent me the data for all the rest of the Moon in these what are called elevation models, so I can actually get 3D craters for like almost every crater on the Moon, front and back side. I mean, it's beautiful. And so we are doing that now. The Moon is available. I have.
And you
all
have,
of Mars.
well, here's the thing. You have pretty much the whole Moon covered now, right? You have the geological data, pretty much the entire Moon.
Pretty much, yeah.
Now we had talked about maybe doing having a whole bunch of the popular craters, because obviously a lot of people want them, like Tycho and Pythagoras and Clavius and whatnot.
Aristarchus.
But people would be able to actually ask for one, correct?
Yeah. If you have a favorite crater, you can just say, "Can I have a crater? I'm looking for this crater." Like you did the other day. I still haven't sent it to him. Sorry. Keith said, "I want Jackson." So I went on the Moon, and Keith didn't know I did it. Okay, but I went on and I grabbed Jackson. I created the relief. I downloaded the digital terrain model of Jackson from the USGS, and I printed it. Now, all the craters are around 4¼ by 4¼ in size. It can be a lot larger, a lot smaller. But 4¼ seems to be a nice size.
Yeah, and I think that should be our standard size. Like if somebody
I agree.
one, it'd be a nice 4¼ And what I'm going to do is I'm actually going to make a video with the craters I have here. Maybe I'll wait for the Jackson one. And here's the cool thing about it. I told Mark about this in passing that I love Jackson crater because of its similarity
Uniqueness.
to Tycho,
Yeah.
and it's almost considered Tycho's twin. And he was actually able to get there and print it out. He sent me the picture, and this. And kudos to you, Mark. He actually went outside and was taking pictures of it in different sunlight angles to show me. And these 3D printed craters, I mean, they are down to every nook and cranny and bump. They are just so well done, and the data is there. I'm not sure, I have no idea what goes on with all this data. I mean, that's obviously your area of expertise. But the craters that I do have, I know Heidi has one, Paul has one, Bill has one that we were able to get when we actually were up at Mark's house back in May. And everybody that I show these to, even people that aren't even into astronomy or the Moon or anything, I show them these craters, and I find them sitting there just looking at this thing, feeling it, looking really close at it, because you're actually seeing crater ridges. You will, if they're complex craters, you will actually have the ejecta coming out of the
central
top.
uplift. Yeah.
I have one here that has a crater printed right on the side where the cutoff was, and you can actually see that one side of the crater is just a tad bit higher than the other side. I mean, they are done to the measurements provided by the geological data of the Moon, and they are really amazing. Now, we're not sure what that he's going to charge for them, but we were thinking if we made them, because a lot of people, we have so many people here that are normal that come in and watch this Moon every time. How cool would it be for you to have your own, crater? And we'll do our best to make them really affordable for you. We just think it'd be something neat for all channels, for this channel, for Mark's channel, for Bill's channel, to actually have these for you guys, that we'd be able to ship them out, and for you guys to have, because they are absolutely amazing. And I think NASA might be doing something similar, but I don't think anybody's just concentrating on printing like individual craters for people. You know,
No, like,
especially if they have a wayward crater that's not really a popular one that they like.
Yeah,
I
like-
want to know more about.
Like on Mars, I did Gusev Crater where we landed. Was that Curiosity, right? Was that or was that Spirit? Where Spirit land? Well, one of the landers was there, and so Gusev Crater. I printed out Gusev Crater. Beautiful detail, you know, and you know the Mars data is wonderful. Malin Space Science Systems actually did this laser altimetry of Mars. It's actually MOLA. It's called MOLA data, MOLA, Mars Orbital Laser Altimetry. And this MOLA data is available in these giant files, and what you could do is you can break it down and you can actually get specific areas on Mars really easily. And so with the USGS guys, I've learned how to convert this stuff, and they're working with me now to convert some of the lunar data. And I create these little models, and they're accurate. I mean, I printed out Mount St. Helens here on Earth. Of course, you can get the Earth, too.
Yeah.
And I printed out Mount St. Helens.
Olympus Mons would be a good one.
Olympus Mons, I actually have one of just Olympus Mons, and that's actually really pretty because you see the scarp very clearly. And you have to understand, if you go to just the regular one-to-one, if you go just to the regular one-to-one scale, altitude scale, then most of the universe and most of the solar system looks flat. The relief is not that high because of the size of these objects. So we can exaggerate the vertical scale to make it more dramatic, or we can leave it like it is. It's really cool.
Let me answer Eduardo's question in the chat real quick. Eduardo asks,
I have Eduardo. I do have Apollo 11's landing site. I actually downloaded that and got a digital terrain model of it the other day.
I think he's asking if we can see it on the stream. Eduardo, no Earth-based telescope is going to be able to see any of the Apollo landing sites. It's just too far away. It's too small of an area. We don't have the resolution to be able to do that. And we could be using the biggest telescope on Earth right now. We wouldn't see it.
Well, even Hubble. I mean, even Hubble and the James Webb. I mean, you gotta understand. I wrote an article on the Huffington Post, which you can look up if you want to. If you look my name up with Huffington Post, there's gonna be an article that I wrote, and it talks about. I think it's an article. Did I write it as an article, or did they just post it? Where I talked about the Hubble.
I think you actually did pay. I have your Huffington Post thing bookmarked, but if anybody else does, like Amanda or. Amanda probably does. She has everything. But if you see
Amanda's fantastic.
I see it. She's great.
Object.
Amanda, link if you have it. Link everybody to Mark's Huffington Post where they can read any of the articles that he's written. There's like a main page that has all of them down through there. Really interesting read.
Yeah,
sorry, I'm writing down object times.
That's fine. Yeah. Well, no, that's a priority. You want to take care of that. I get that. I totally get that. No, I'm. It's actually not a. I know that I wrote. I don't know if I wrote the article or if I did it in a post.
There you go. She posted it for you.
Yes, she did. But I'm wondering if I actually did do that as a post or if I. Well, I'll find out in a second.
But really interesting reads on that. I was actually quite content and sitting there and actually read through 3 or 4 of them at one time.
Yeah.
Granted, I was waiting for the Eagles game to start, so I was like waiting for something, so I read through them. But yeah,
it's actually a post. They're only a post. It was a post I put up on the on Facebook. It was not a. It was not a actual Huffington Post article, but that's okay. I mean, bottom line is. The Hubble Space Telescope, I get that question all the time. If Hubble can see these deep sky objects, why can't it see the lunar lander? And it really comes down to the resolution of the Hubble telescope. When you look at the moon, all right, let's take the Apollo 12 landing site. The lunar module landed 120 feet from one of the craters, okay? And that 120 feet, all right, on the Hubble sensor was literally only about a pixel on the Hubble sensor, maybe a little larger. Now, you have seen many different photographs in your lives, all of you guys. And when you look at photographs, you've never seen a photo that consists of 1 or 2 pixels. photos have minimally 300 by 200 pixels, and those look crappy. 640 by 480 is crappy. And looking at 1920 by 1080 is reasonable. It looks good, you know, to your eye. So 1 or 2 pixels, remember, a pixel is just one color. So you're not going to get a multicolored pixel. So the bottom line is that you know any of these landing sites, and thus the traverses, the excursions, the EVAs that they took to walk around on the moon, you know, extravehicular activity, you know, that they moved to when they moved around the moon, all of those literally on the largest moonwalk just correspond to just a handful of pixels on the Hubble sensor. So you see, you can't see, and again, that's why Hubble can't see planets directly unless they're in very favorable conditions, okay, around other stars. So, you know, we're talking about this type of resolution problem that we have with the Hubble. Now, the James Webb Telescope is going to have, you know, it's going to be a 21-foot diameter mirror as opposed to about 8 with Hubble, and it will have better resolution. And so, you know, but it's going to be parked far away, and we're not going to be able to look at the moon on the near side where we've landed.
Where are they actually parking the James Webb at?
I think it's going to be at one of the Lagrange points out past the moon. I got to look that up and get the exact location. Because I was trying to work out what it was going to take to hold it there. You know what I mean?
I thought for some reason I was reading that it was out somewhere near Mars and Jupiter.
Well, it could be. I mean, it's going to be at a Lagrange point, I believe.
Yeah. Well, anyway, back to these craters, okay, Mark. This is what I need in order to do a nice commercial for you. Okay, I need Clavius. I need Aristarchus. I need Pythagoras.
I have Aristarchus right in front of me.
All the ones on the South Pole, and I need some mare areas too, if that's possible. You know, just send me all them, and I'll make a nice video for you. And that, ladies and gentlemen, is how you get free craters. Well, they are great, though, man. I mean, they are absolutely fascinating.
The other thing you left out is I actually researched the colors, and you know, let's take Aristarchus for instance. I have that in my hand. Aristarchus actually has some bright material that heads to the west of it and to the southwest, and it has some bright white material inside the crater. And when you take a photograph of it in the sunlight, the white looks very overexposed and very bright. However, it's actually quite subtle in real life. And when you look at it, you could almost mistake it for just a slight variation in the gray. But when you photograph it and you have the camera set up to look at, you know, and meter for the gray, the white gets really blown out. And that's why we see Aristarchus with this bright white on it. And I can't say enough. Go to the Lunar Reconnaissance Orbiter website. Actually, look up LROC, L-R-O-C, space, quick map. All one word, and it's a site sponsored by Arizona State University, ASU, and you can zoom into literally half a meter per pixel on the moon.
Amazing detail.
Yes, you can see all the Apollo landing sites. You can see all the lunar module descent stages. You can even see the flags, the shadows of the flags, and in some cases the flags themselves. If you know where to look and if you're looking carefully.
That actually brings up a question I have for you. Go ahead, continue your thought. I'll ask you after you're done.
But to see that, when you go in on the left side, you're going to see a little stack of folders kind of a thing, like they use. It's a metaphor they use to get to open up into a lot of other folders. And when you click that, down comes this large set of overlays and other data that you can view and superimpose on the moon. One of the ones you want to do is just click the first one, okay, that just says overlay, and that opens up this next set, and that next set has things like nomenclature and crater names and so forth. One of them that you're going to want to click on is featured LROC images, okay, featured images. You click that, you see all these little yellow dots, which includes all the Apollo landing sites, all the Lunokhod and Surveyor landing sites, both Russian and American there, and even the Chinese lander is updated on there and you can see the paths by these rovers. You can see the path by all the astronauts, the paths they walked. You can see it all very clearly. And this is stuff that you can just zoom into on the moon. It's just wonderful. So again, I can't say it enough. It's the LROC Quick Map browser. Darryl just put up the the one, but actually Amanda did it just before him. Very good. Thank you guys. You're wonderful. I'm so proud to have those guys in my Sky Tour live stream. Amanda does such a wonderful job.
Speaking of Darryl, were you listening the other? Now, Darryl, I hate to put you on blast again, bud, but I'm running this by everybody. I had Bill on the other night. Were you? Did you by chance get to hear that or no?
Amanda told me that was going on, and I just couldn't do it. I wasn't home. I was in the middle of doing something because I had a computer down and I had all kinds of stuff going on. And I was really irritated with my computer world, so I had to focus on that. But no, I did not.
No problem. I had an idea for Darryl.
Yeah.
Because he is a wealth of knowledge. And I was trying to get him on tonight because I would like a stream, whether it be here or preferably on your channel, would be great because of the wealth of knowledge you both have. To actually get him on. But the one thing I want to do is I proposed this to Darryl about him picking a topic. Okay. Any topic he wants to in the field of astronomy, whether it be the moon, its craters, its whatever, it doesn't matter. Saturn, galaxies, pick whatever he wants, and actually have him write a script about it, an educational script. And then I told him that either he could do the voiceover for it, or I would do it, or we have many friends that have voice talents that could actually read that script, and then I would do the video for it. And I think it would be a really good, because he is a wealth of knowledge just like yourself. To actually make educational videos about a certain topic. And I'm not putting any bars on him. Like, he can make it about whatever he wants to, whatever he wants to teach about, or he might think people would find interesting. And I just thought it'd be a really neat addition. And once again, I don't know if he has his own active channel or not, but I told them or him that I wouldn't mind making a video that he could actually post to his channel if he wanted to. You know what I mean?
Why don't you bring him in, because he's probably going to be willing to talk here in a few seconds.
What's that?
He'll probably be willing to talk in a few seconds, so why don't you bring him in?
Oh, well, he was saying he was just kicking back and listening earlier, so that's why I was going to bring him in earlier, but he said he was just going to kick back and listen to us. But there's another one. Oh, incoming. Ooh. Probably a bird, but I thought that'd be a good idea for him. I do want to get some people on the stream that I haven't really had a chance to talk to one-on-one now that we're talking about it, but I would love to get Dee in on one of these Skype chats just to chit-chat with her. She's been a loyal follower of all three channels. Sir. I'd love to chit-chat with her a little bit. She's been, moderating for me for well over a year now. Very cool person. Would love to get to know her better. But I think having you and I'm actually going to bring in Darryl here in a second. But
cool.
If you two can try to save some goodies for your channel, because I think that's where it's going to be most beneficial. Especially with you running the telescopes and whatnot, and you having Amanda there to relay questions about stuff that Darryl obviously knows, so he can be there to help you out while you're running Sky. I just think it would be a great combo.
And Amanda actually asked some really good questions herself, And by the way, I just have to say before we go on there, these craters that we're talking about, these 3D printed craters, if you want to see more about them, we're preparing a post. My Colorado guys, Jude and Sarah, are preparing a post on the FX Models Planetary Replica companion site on Facebook, and we're going to have images of these craters. We actually, when we were in Devil's Tower, Wyoming, we're actually I put one of the craters on a wooden plaque with a brass plate. That's one of the options. And then what I did was I put it in the silent auction. And it was actually one of the planets we have, which is a dwarf planet, which that I didn't mention before. We have Pluto. Mm-hmm. We have Pluto's terrain, and it's so different from any other terrain in the solar system. And it's whitish, and there's some areas that are red, rusty red. And so I took a slab of Pluto, a square 4.25, 4¼ by 4¼ square of Pluto, put it on a wooden plaque, a brass plate, and I put it in the silent auction. And don't you know that thing bid it up higher than anything else? And it went for the highest amount of anything in the silent auction because they saw it and they said, I got to have Pluto, wherever it was. So they just kept bidding on it, bidding on it, bidding on it. and they ended up getting it, and I thought that was pretty cool.
Awesome.
So we're gonna get everything up there. You got Darryl in now?
I believe so. Darryl, with us.
Yeah, can you hear
There he
me?
is.
There he is. How's it going, my friend?
Oh, just fine. How are you? Hello, Mark.
Hey, how you doing, Darryl? How's Colorado?
The sun finally came back today. It's been
Oh no,
cold
it's dark
and wet
here.
all week long. But the sun came out today. It's supposed to be even nicer tomorrow, so
That's good.
hopefully we're back to more typical Colorado fall weather.
Right.
First time I think I've talked with either of you guys, so hello and thank you for having me on.
Yeah, and Darryl, let me just say before you say anything else, because I want you to really know how appreciated you are between all three of these channels for giving out
Absolutely.
the information that you do and keeping up with everybody. It's real. You really become an asset to all three channels, and I just want to thank you for that, and how it's much appreciated.
Well, gosh, thanks. I don't know what to say. I discovered your site one night, Keith, and just started watching, and then I started chiming in. The thing I worry about is that I don't want to take away from what you guys are doing on your own streams. Okay? I mean, if I talk around the edges of what you're doing, just to sort of expand a little bit on what you're talking about, or maybe in Mark's case to approach it a little bit more from a amateur point of view, shall we say, I'm happy to do what I can to help.
Well, you're a hell of an amateur if that's what you're calling yourself. I mean, you've got a lot of knowledge there. You know, a lot of people don't realize just how much you do know. And I'd be proud to have you as a research assistant on any project I do. You know, or I'd follow your research. You know, if you were doing a research project, I would be involved there too, from a point of view of how can I help you? You know, I mean, I think you do a good job, Darryl.
Oh, well, thank you. But still, I mean, I fear sometimes about I don't want to take away from what you're doing, and I don't want to overrun what you're doing.
Not at all.
And I'm way past doing research. I'm retired, okay? I just kick back and try to enjoy things.
That's awesome.
As for the amateur bit, I want to chime in here because Keith was talking about it a few minutes ago, trying to get me to help in production of videos, you know, from my point of view, I guess, and doing what I can. If I do it, I can't guarantee that I'm going to do it, but I'm researching it now, shall we say. I would want to approach it from an amateur's point of view. That, I can rattle off numbers, but that's not what I'm about. I can talk, I know a little about a lot of things. I know a lot about a few things. I don't claim to know everything, okay? As far as amateur astronomy goes, I've been doing this for going on 40 years. I've had a lifelong interest. I got my first telescope when I was mid-20s. I was living up in the highest city in the United States at over 10,000 feet elevation. I had a paycheck burning a hole in my pocket. And since I had always been interested and had been reading Sky and Telescope for a while, I bought myself an Edmunds Scientific 6-inch f6 Newtonian reflector. And that was my start. I got spoiled living up where I did. It's a town called Leadville, Colorado. It's way up. It's the highest town in the Rockies, 10,200 feet elevation. I was totally spoiled by the skies there. And it's been hard to compare anything to that ever since. I did public astronomy programs back in the 90s, starting on my own. Just when I would go camping in the summer, I'd drag the scopes along, and by then I had a whole lot more than a 6-inch reflector. And then I joined the local astronomy club, and still doing programs on my own, but also doing programs in conjunction with the local astronomical club. I digress. If I were to do videos, I would do them from an amateur's point of view, and my thought would be sort of an astronomy 101, how to introduce people to the sky. Mm-hmm. why the things in the sky do what they do, to try to relate to laymen what they're seeing and how to understand it.
Well, truthfully, Darryl, I mean, I probably wouldn't want you to approach it any other way. I mean,
Okay.
if we wanted to get down to scientific mathematics, you know, and really into it, that's what this other guy that we're talking to is for. You know what I mean?
Absolutely.
But we because I mean, I've gotten so many messages from other amateur astronomers saying that just from them watching the stream and, you know, learning what they could from in chat from people like yourself, from Mark, from me, from other astronomers that we have, from like Joe Malone and Dustin, you know, the guys that come in, they learn so much, and it's because of those layman terms and almost astronomy 101 that they gather the most information. So
Yes.
I would almost, I mean, rather do it, you know, it's exactly how you said, you know, from an amateur point of view, it helps people understand it a lot better. It gets them into astronomy a lot more when they're not constantly having to think about numbers and crunching and geometry, you know. But once again, I don't want you to feel as if I'm like, you know, oh, we're gonna have to do like a video a week or anything like that. It's whenever you want. It doesn't. I mean, a video a year would be fine. You know what I mean? It's just a matter of it's just another, basically. I just thought about you when you were doing it because you are such a wealth of information, and which is why I decided to ask you about it, because our main goal here is to educate people. That is our number one goal.
Sure.
You know, and if we and how you post, you know, believe it or not, even if you don't get a response from something you post in chat, somebody that was looking for that answer has seen it. You know,
and I agree with that. I've seen, you know, I've talked here in your stream on things, and then saw my words reiterated elsewhere, like the following day in other you know, avenues. It's like, wow, that's pretty cool, you know. And I think, like, you know, what Darryl's saying to me, that sort of resonates with me, because I'm all about trying to explain what has been classically considered unexplainable. And so I will tackle topics that, you know, typically would require tremendous knowledge of mathematics, okay, or scientific understanding, and try and put it in terms that everyone can understand. And the reason is because everyone needs to know this stuff. You know, we are advancing as a civilization, and so we need to know this stuff. Right. If you have any serious interest, if you want to know about the sky, if you want to do battle with the flat earthers, if you want to talk to people who say we never went to the moon, you need armament to be able to you know, discuss that. And what's that armament? Well, that's Darryl's information, my information. I mean, that's it.
Education,
you know, knowledge. I mentioned earlier tonight in the chat, there was an article out a couple of days ago about the failure of science education in the United States.
Yeah.
And I have believed this all my life. I find it distressing. It's not just that the kids aren't learning, but that the teachers aren't teaching, and the teachers aren't teaching it because the teachers don't understand it either.
That's right. That's right.
Yes.
Neil deGrasse Tyson feels that way too. You know, and that's something that you know, I have in common with him. You know, we both think that. I was a teaching for a long time, and I was appalled at the lack of basic understanding that I was faced with.
Right.
Absolutely. Anyway, I would hope I could try to, you know, put a crack in that just a little bit. Again, back when I did public programs, back in the 90s, I worked with the Colorado State Parks a lot, and I did it for free, basically. They give me a camping spot, and I'd give them a public star party and a program on the Perseid meteor showers or stuff like that.
Yeah.
This was back in the 90s. I didn't have digital anything. Okay, I used a flip chart that I drew myself, and later on I bought some slides, and we'd do a slideshow, you know, stuff like that. It was a different time. But I tried to relate with the audience, the layman, on their terms and try to keep it simple, KISS, you know, something they could understand. I would tell them some of the sky stories, stuff about the constellations. People, one thing I found, always are curious about their zodiacal sign, okay? A lot of them were amazed that they could actually see them if they would bother to go out and look up, and if they knew where to look. One program I was doing one year, you'd get all sorts of people there, you know. Well, one year I had a young lady from Wellesley College in the audience, and she was, pardon me for saying, but she was just unbelievably stuck up, okay? I go to Wellesley and you don't, you know, that sort of thing. Well, she was a Scorpio, and I showed her how to find the constellation Scorpius in the sky. And all the rest of that night, she was not a stuck-up Ivy League, whatever, college student. She was a little kid giggling and running around and pointing to everybody, and she could get their attention. I'm a Scorpio. There it is right up there. See? Do you see the tail and do you see the heart and all that stuff?
Yeah.
And that's the kind of thing where I might have 100 people or more at one of the programs that I did. And I always felt that if I could reach just one person in that audience, that I had succeeded for that night.
Yeah.
You know, that's kind of where I was always coming from.
Well, you know what, Darryl?
Yeah.
I mean, my idea and basically was to let you pick a topic for any. I mean, it can be anything you want. You know, just something that you find interesting that you think other people would too and might want to learn more about. Like you were talking about those craters the one night. The name of them slips my mind at this point.
Katina Davy.
There you go.
Yeah.
Mark and I talked about it too.
Yeah, we did. Yeah, we have a little. We were going back and forth. Katina Davy is an interesting feature because, on one hand, it looks like it could have been a stone skipping across the water type effect, with something that skittered across the surface. But I think, you know, and Darryl had his opinion about what it is too, which he'll tell you, I'm sure, you know, again. My personal feeling is that it was probably a collapsed lava tube beneath the surface, and that's how those look as well. And they typically will have a sinuous look, but that one's kind of particularly straight. So that's why there's conflict about what it might actually be, you know. But I think that it's a straight section of lava tube that collapsed.
And Mark, I tend to agree with you. Actually, I've read both ideas that it's a collapsed lava tube, or it's a chain of impacts. I saw an LRO close-up of part of Katina Davy, and it was 4 to 6 craters in a row touching each other. The craters were square, okay, and it looked exactly like what it would look like if the roof of a lava tube had collapsed. Yeah. But you know, in the end, who knows? It could be either. But it's really cool to look at, whatever it is.
It's a very cool feature. You know, it's like the straight wall on the moon is a cool feature. You know?
That's another of my favorites, Rupes Recta, the straight wall. Rupes Recta always looked like a sword to me. It looks like a cavalry saber. It's 60 miles long or so, and there's a group of hills down at one end of it, the south end, if I remember right. Yeah. And that looks just like the grip and the guard of the sword. You know, pareidolia, we talk about it all the time.
Sure.
That we try to make sense of patterns we see or that we make in our own brain.
Familiarize an unfamiliar pattern.
Right. So the straight wall to me has always looked like a sword. And there you go. Anyway, we saw Batman in a crater on the moon one night at a public star party we were doing with the astronomy club here in town. Looked just like the Batman logo, you know. So, anyway,
hey guys, I just want to tell you two, I'm gonna go refill my drink real quick, but you two keep on talking away. You're good to go.
Okay.
All right, thanks.
No worries.
Mark, I'd like to ask you a question now that I have you.
Oh, sure. Go ahead,
I sent you through Skype a message the other day when that fourth LIGO event happened.
That's right.
Did you get that message?
I did, you know, and I didn't get a chance to respond. I was telling folks earlier, you might have been in here actually. in my shop here, right, I do all my visual effects stuff, and I actually make models for the Navy and stuff. My laser cutter is like a primary piece of equipment, and it went down. So I had to actually buy a new laser cutter, and that came in, and I ended up having to. Oh, look at those shadows! That's beautiful. Another one came in, and I had to install it and put it in. There's so much to do. I had to get the airflow across the nozzle. I had to do a water bath thing. All kinds of stuff. So I just got that running today, and I just cut the remaining bases for this sub suite of models that I have to send out to General Dynamics in Falls Church. But then my machine in my shop, my main office here, my machine crapped out in the main office. Right on the heels of the machine in the observatory failing. So I don't know what it was, but I fixed the one in the observatory. It seems like it's okay for now. But then the one in the office here crapped out. But that's why I've been sort of aloof lately and not really.
That's fine. That's fine. I know work before pleasure. And as I said, I mean, I'm retired. I'm just sitting here twiddling my thumbs. What I wondered about that fourth gravitational wave event that was detected a few days ago, I'm sure you heard about it.
I did.
Yeah.
It was a non-LIGO instrument, right? The one that detected it.
No, both LIGOs and the Virgo detector in Italy, I think it is, detected it. So
yeah, that's what I meant. It was the Virgo detector was the oddball out. It was the odd one because it's not a. It wasn't part of the LIGO network. It was a different detector.
Right, but using the three detectors, they were able to triangulate and get a much closer fix on this event. For those in the audience that hadn't heard of this, perhaps you've heard of the LIGO detectors that have detected gravitational waves from black holes or neutron stars merging or colliding. There was another event recorded a few days ago. It's amazing they can figure all this out from the information they gather. But they say two black holes joined. One had 31 solar masses. It was 31 times the mass of the sun. The other was 25 solar masses. And the article also mentioned that 3 solar masses worth of matter got converted into gravitational wave energy.
Yeah, if you think about that, that may not mean a whole lot because you hear, well, 3 solar masses. But keep in mind how many Earths would fill the sun. Okay, if you were to fill the volume of the sun, I mean, that number is stupendous. It's like I think it's like 1 million Earths, isn't it? Something like that. Something ridiculous.
It's a lot. I remember that. I don't remember the number.
But 3 of those.
To relate to the layman, perhaps, I enjoy watching the old Star Trek original series reruns on BBC America. And just recently, they reran the old And What of Lazarus episode, where the guys, they look like twins. They're from 2 different universes. They're fighting in one than the other. One is insane. One's a good guy. But when these events would happen, when they would jump between universes, Star Trek got on the horn, Starfleet got on the horn. Oh my God, it practically ripped apart all of space-time. What if you were anywhere in the neighborhood of those 2 black holes when they collided? What would 3 suns worth of energy do to local space-time? I mean, those gravitational waves. Would you feel it if you were on a planet? Would it distort? Would it destroy? That was basically the gist of what I was asking in my question.
Yeah. Well, first of all, to answer that question, you need to understand, the magnitude of the burst, and they don't really, they don't have anything but cursory information about it. There still has to be, reduced data first.
Sure.
But one of the things that's interesting is the gravitational waves, when they emanate out, we didn't know for a long time whether gravitational waves would travel at the speed of light. All right. Now, it's been surmised that gravity and gravitational waves, or gravitons, will travel at the speed of light. Yes. So that means that, and this emanation now from these neutron stars merging, or whatever, these black holes that are merging as well, this could be a spherical emanation, or it could be planar based on the geometry of the and so forth of the magnetic fields, how they interact with each other. Those drive a lot of this. It's why some planetary nebulae are what are called bipolar. It doesn't mean they don't, that they get set off very easily. It means that they're, they have a area that looks like more is coming out of, say, the north and south, or along the equator, more likely. So this asymmetry you see in such a thing is a possibility. Now, we don't know that yet with gravitational waves. We don't know whether they're spherical emanations, and we're actually seeing the edges, which there's more gravitational wave effect seen when you're looking through more of it. All right, and then in the front and the back, we don't see it, so we don't know that yet, kind of a thing. So there's a long way to go in understanding it. But so as far as the intensity, if it's a spherical emanation, then it's going to be diluted somewhat as it emanates out, and if it's if it falls off and as light falls off, it's going to fall off at the square of the distance. So in other words, if something is twice as far